this maths tutorial. Today we are going to learn the continuation of the previous video that is called in the triangles chapter. So here we are going to discuss a very important theorem called Thales Theorem. 95% you can expect this theorem in your exam, final exam. So very careful about this theorem. Study now itself. It's very easy and very simple. You should know what is the area of the triangles formula. Only that much, and you have to learn some concept here. So let me start with this. See here in exam they'll ask you write the Thales theorem and prove it. Proof of that. So prove it. Both they'll ask. Otherwise they'll give the statement, the theorem they'll give you. They'll ask you to prove that. So in either way they can ask you. So you have to study the theorem and you have to study the proof also. Not only the proof, you have to study the theorem as well as you have to study the proof. So what the theorem says, let us see. So before that, this comes under the similarity of the triangles. Similarity, we have studied what is similar figures, everything we have studied in the last class. So here similarity of triangles, under that comes the basic proportionality theorem. We call it as the basic proportionality theorem, or we can ask, that's called Thales theorem. So in either way they can ask you. If they ask you basic proportionality theorem, you have to write this theorem only, or they can ask you the Thales theorem. That time also you have to write this theorem, the statement and the proof. The statement is very important. So see what is the statement says. What does the theorem says? See, the theorem says if a line is drawn, how to draw? Parallel to one side of the triangle. So first you should have a triangle, isn't it? So then what you have to draw? A line is drawn parallel to one side of the triangle. How it should be drawn? To intersect the other two sides. It should be intersect. Intersect means you have to pass it, isn't it? So you are not, it have to touch that line so that it is intersecting. Intersect the other two sides in distinct point. Not at the same point. Two lines are intersecting at the same point means this is intersecting a point, isn't it? So they have asked you to, it should be in a different point. It should not be in the same point. It should be in a different points. I hope you understood. So it should be in a distinct points. The other two sides are divided in the same ratio. What is that? See, when you are drawing that intersecting line, then you can say that two joins a line, isn't it? That is intersecting. If I say that this is intersecting, so you can see here, isn't it? Of this is a triangle. So this is a triangle. If I take a 2 points, that is intersecting, and you can see this line is parallel to this line, isn't it? It should be parallel to one of the side. So you can see these two are parallel, isn't it? Parallel means these two lines are like this. This is called parallel line, isn't it? So here, this way also we can say parallel lines, isn't it? It should be in same, the distance should be same and keep on moving. That we can say the national highway, isn't it? It's like in the parallel. So here we can see that two should be in a parallel, and what says here, the other two sides are divided in the same ratio. See, these two sides, other two sides means these two sides should be divided in the same ratio. This is divides, isn't it? This line is going to divide that two. It should be divided in the same ratio. This should be equal to this. That ratio should be same. That you have to prove it. This ratio should be equal. That you have to divide in the same ratio. That you have to prove it. How you have to prove this? So what is given here? According to that, you have to draw a figure. Then what you have given, that you have to write it in the data. And what you have to prove what you have to prove, that you have to write it here. And next you have to write what the construction, extra drawing you are doing, that you have to write it in the construction. Then you have to go to prove the theorem. I hope you understood. Now there are 4 steps that you have to see. Before that we will draw the figure. Now I hope you understood with the figure. See here what they asked you to do. See, you want a triangle. You want a a triangle. That triangle is called ABC. Got it? So what you have to do, if a line drawn parallel to one side of a triangle, I have taken BC as the one side, and for that have drawn a parallel line here as DE. Got it? That parallel line have drawn to intersect the other two sides, intersecting the other two sides at different distinct point, not at the same point. You can see here, this is a different point and this is a different point. If those two are in the same point, means it should be intersect here, isn't it? It should be a same point, but it is these are different points. You can see. I hope you understood. So it should be intersected at a distinct point. The other two sides are divided in the same ratio. These two sides are divided equally. That we have to prove it in the same ratio. That you have to prove it. Okay. So now we'll write down what is the data given here. Into the theorem, I have drawn the triangle. I've told you how to draw the triangle. Now after that, what is drawn or what is given in the theorem, that is data. What is given in the theorem and what you have drawn, that is called data. So what is data? I have written in triangle ABC, the line drawn parallel to the line in triangle ABC, the line drawn parallel to BC is intersects AB at the point D and intersects AC at the point E respectively. I have written. Okay, I hope you understood. Intersects AB and AC at D and E respectively. So what we have drawn, that we have to write it. So I hope you understood. Now we have to see here prove. What to prove? That is also here in the theorem. What we have to prove? We have to prove that two sides are divided in the same ratio. That means this side and this side should be equal. That you have to prove. That is, the ratio means AD divided by DB should be equal to AE divided by EC. See here, AD divided by DB should be equal to AE divided by EC. So this divided by this should be equal to this divided by this. That is means these two have a same ratio. So I hope you understood this. Now to prove what is you have understood. Now what we have to construct to prove that. So that is in the construction what you are going to do. Here onwards you are doing your own way of, it's not in the theorem. So what we are going to do, that is you have to write it in the construction. What extra you are going to draw here to prove this theorem. That is in the construction. So what is the construction says here? You have to join BE and CD. You have to join BE and CD. You have to join. So what the construction you are doing, you have to use the dotted line to show that that is the extra work you are doing it. So the dotted line you have to draw and join this DE. So join BE and CD you have drawn, and you have to draw DM perpendicular to AC. AC means this is AC. So you have to draw a line, should be perpendicular. So you have to draw a line from the point D that should be perpendicular. So perpendicular means you know that this is perpendicular. So you can see it's 90 degree, it stands perpendicular. Got it? So you have drawn, that is DM. Here you have drawn DM, that is perpendicularly standing. This is perpendicularly standing to the line of AC. Similarly, DM is perpendicular to AC. Similarly, what you have to do, and EN is perpendicular to AB. That means from the point E, you have to draw a perpendicular line to AB, this line. So N. So here also you can see there is a perpendicular. You can see here also we can see the perpendicular, isn't it? So now you have drawn what is the construction is over, isn't it? Now what we have to prove here. See, you can see here if it is constructed like this. Now we have to use the concept of area of the triangle. What's the formula called? Area of the triangle is nothing but half into base into height, isn't it? Area of the triangle is nothing but you have to use this formula here, that is half into base into height. So you have to use this formula. Now here I am going to consider which triangles that you have to see. Which triangles you have to consider. Here you can see, if you go for taking, there are different triangles when you have constructed these lines, isn't it? So here first you have to take which line and which ratio you have to take, then what you will get, that we are going to do in the proof. Hope you understood. Now move on to the proof here. Consider the two triangles here. The ADE, the area of the triangle ADE, and I am going to take the area of the triangle. Here you can see a triangle, isn't it? Here BDE. Here you can find a triangle, isn't it? Here one triangle you can find out. It's in the shape like this. It's in the shape like this. Here you can find a triangle DB, here E. You can find a triangle here, isn't it? So this triangle and this triangle I am going to take it now. First I am going to find out the area of that. So I am writing E. So what is that? Area of the triangle of BDE, nothing but half. You can see here ADE. Here you can see this is a base ADE. Here you can find this is a triangle ADE. Here you can find this is a base, and what is the height? You can see height, you can see here, that is nothing but the height of this EN. EN is the height. You can see this is a height, altitude of the triangle, that is nothing but EN, that is the height of that triangle. Got it? So this you have to write it as EN has the height. So how to write? What is the base? Base is AD into what is the height is EN. Similarly, divided by what is the area of the triangle BDE, and is this one, and here what is the base is? Base is BD. Here base, isn't it? DB. DB is the base, and into what is the height of that? Height is nothing but, here you can see this is a height, isn't it? So when we are drawing that perpendicular line here, so here DE, that we can see here, this is EN. This altitude is the height, isn't it? So you can see that NE is the height here, because D is equal to this NE. So you write it, you can write EN is the height here. So you know that EN get cancels, here half get cancels, you get here AD by, you will get here AD by DB. This you have to take it as equation number 1 here. So this you have to take as equation number 1 here. Similarly, you have to take the next triangle, the triangle ADE divided by area of the triangle CED. Next one is CED. That the area of the triangle ADE divided by the area of the triangle CED. Here also you can see a triangle here. Can you see this triangle here? This shape. You can see here a triangle in this shape, isn't it? ECD. You can see this triangle. And one more here, ADE. Here you can see this is a base here. This side is a base. AE is a base. So you can write. And what is the height here? Height is nothing but the DM is the height. That we have drawn the altitude here. This is the height here. So you can write half into base is AE into what is the height is DM. Whole divided by here half. And what is the triangle here? This is nothing but CED. CED. Here you can see the base is this one. That is nothing but EC is this base. And what is the height? Height here. The height is nothing but ED. That is equal to DM only. So you have to write that is DM. So D and DM get cancels. Half get cancelled. You will get AE divided by EC. This is equation number 2. So I hope you understood till now. Now we have to see what is the last one. You can see here the triangle BDE. This triangle, this one, the triangle B. See here, you can see the triangle BDE. This triangle and the triangle this one. See, if you consider these two triangles, this triangle and this triangle, if you consider, you can see the DE is the same base for that two triangle, isn't it? If you consider it like this triangle and like this triangle, this is the base if you are considering DE as a base if you are considering, that you know that this DE is parallel to this BC, isn't it? This base, that DE of these two triangles, it's parallel to this BC, isn't it? So we can say that these two are equal. If these two, the base of the two triangles is same, then we can say that the two triangles are equal, isn't it? So we'll write down that BDE and triangle DEC. Triangle BDE and the triangle DEC stands on the same base, that is DE. These two triangles stands on the same base, that is DE. And we have already seen that this DE is parallel to this line BC, isn't it? These two are, see here, I have written the same base DE, and in between this DE is parallel to BC. That means that two are parallel. So therefore the area of the triangle, BDE is equal to the area of the triangle DEC. I hope you understood. The area of the triangle of this triangle is equal to this triangle DEC. So if these two are equal, then you have to say that this is an equation number 3. Now we have seen this divided by this, what we have got, and this divided by this triangle, what we have got, and we have telling that this is equal to this triangle. These two are here. We have taken this is equal to this, and this we have done, and now we are telling these two are equal. Then we have to say that from equation 1, 2 and 3, according to the first equation and second equation and from third equation, we know that if these two are equal, then you have to take this is equal to this. From equation 1, 2 and 3, what we will get? AD by DB is equal to AE by EC. So what we have to prove here? AD by DB is equal to AE by AC. So our proof is over. Now I hope you understood this theorem. So study this, very easy. So those who have not subscribed my channel, subscribe it. We'll come with the next video. So hope you are doing fine. Have a nice day.